Good afternoon, all. Myself, Dr. Abhishek Tiwari. Today, we are going to discuss unit processes in extractive metallurgy. So, this is the outline of the presentation. First, we will discuss what is the scope of extractive metallurgy and then occurrence of metals in the nature, and then minerals and ores and elementary concepts of mineral processing and theories of comminution and pressing and grinding equipment and their fields of application and limitations, laws of settling of solids in fluid type of classifiers and in their selection and performance. So, what is the scope of extractive metallurgy? Basically, extractive metallurgy is a very important subject of metallurgical engineering in which processes and methods of extraction of metals from their natural mineral deposits are studied. The ferrous and non-ferrous extractive metallurgy have its facilities that can be categorized into mineral processing, hydrometallurgy, pyrometallurgy, and electrometallurgy, depending upon the process adopted to extract the metal. So, occurrence of metal in nature, the crust of the earth provides metals, and it is a good source of a good source of metals, and mostly the metals occur in the nature in a combined state, but sometimes they can also occur in free state. A native metal is a metal found in its metallic state naturally, either in pure form or in the form of an alloy. Most metals can't register natural processes like oxidation, corrosion, etc. Hence, only non-reactive metals like gold, silver, platinum, etc. are found in the native or free state. Most metals are obtained in the form of compounds, and they need to be filtered from their impurities to be further used for various applications. Minerals are naturally occurring inorganic solids with a crystalline structure and a definite range of chemical formula. Ores are concentrations of minerals in rock that are high enough to be economically extracted for use. All ores are minerals, but all minerals are not necessarily ores. Rocks. A rock is made up of two or more minerals, and you need minerals to make rocks, but you don't need rocks to make minerals. All rocks are made of minerals. So what is mineral? A mineral is composed of same substance throughout. There are about 3,000 different minerals in the world, and minerals are made of chemicals, either a single chemical or a combination of chemicals. What is the difference between rock and mineral? A rock is made of two or more minerals, whereas a mineral is composed of same substance throughout. And an ore, a mineral occurring in sufficient quantity and containing enough metal to permit its recovery and extraction at profit. Gangue is an unwanted, commercially useless, rocky, earthy, or sandy material that are found with the ores, and these are the impurities that are to be filtered out at a later stage. So, what are uh, different ores for various metals, and they occur in different forms like oxide, carbonate, sulfide, halide ores. So in form of oxides for aluminium, it occurs in the form of oxide Al2O3.2H2O, and copper in the form of cuprite, that is Cu2O, and iron in the form of hematite Fe2O3, and tin in the form of cassiterite SnO2, and carbonate ores for calcium. It occurs in the form of limestone CaCO3, zinc in the form of calamine ZnCO3, and iron in the form of sideриtes FeCO3, and sulfide ore. So for zinc, it occurs in the form of zinc blende. It's very important. It's asked in the examinations also. Copper glass U2S, and lead, galena PVS. This is also asked in examinations, and Mercury, cinnabar, HGS. This is also asked in the examination. Halide ore, sodium, rock salt. Sodium occurs in the form of rock salt, NaCl. Fluoride ore, that is fluorspar, CaF2, and silver is found in the form of horn silver, AgCl. So these are typical iron ores. You can see how they look like: hematite in the form of Fe2O3, and magnetite Fe3O4, siderite FeCO3, pyrite FeS, limonite FeOOH dot NH2O, ilmenite FeTiO3. Copper ores are found in the form of chalcopyrite CuFeS2, chalcocite Cu2S, covalite CuS, bornite 2Cus dot Cus dot Fes, cuprite Cu2O, azurite 2CuCO3 dot CuOH whole to S. Aluminum ores are found in the form of bauxite Al2O3 dot 2H2O, corundum Al2O3, feldspar NaLSi3O8, cryolite Na3AlF6, alunite KAl3SO4 whole twice OH whole 6, kaolin Al2O3 dot 2SiO2 dot 2H2O. Magnesium ores are found in the form of magnesite MgCO3, dolomite MgCO3 dot CaCO3, Epsom salt MgSO4 dot 7H2O, kieserite MgSO4 dot H2O, carnallite KCl dot MgCl2 dot 6H2O. Calcium ores are found in the form of dolomite MgCO3 dot CaCO3. This is also asked in the examination. Gypsum CaCO3 dot 2H2O. This is also very important for examination point of view. They can ask to match the tables. And fluorspar CaF2, calcite CaCO3, asbestos CaSiO3 dot MgSiO3. Then silver ores are found in the form of horn silver, AgCl, ruby silver, 3 Ag2S dot Sb2 S3. Gold ores are found in the form of calaverite, Au Te2, sylvanite, Ag Au Te2. Zinc ores are found in the form of zinc blende, ZnS, zincite, ZnO, calamine, ZnCO3. Lead ores are found in the form of galena, PbS, angelicite, PbSO4, cerussite, PbCO3. This is also asked in the examination. Titanium ores, rutile. This is very important for examination point of view. Rutile TiO2, ilmenite Fe, TiO3, tin or SNO, cassiterite SNO2. This is always asked in the examination if they ask about ores. Mercury Hg or cinnabar HGS. This is also very important for examination. Antimony Sb or stibnite Sb2S3, pyrargyrite or dark red silver or Ag3 SbS3. Then elementary concepts of mineral processing. Mineral processing, it's also called as ore dressing, is the process of separating commercially valuable metals from their ores. So it has some unit operations like comminution, sizing, concentration, dewatering. So comminution is particle size reduction, sizing is separation of particle sizes by screening or classification, and concentration by taking advantage of physical and surface chemical properties, and dewatering is based on solid liquid separation. So what are the theories of comminution, crushing, grinding, equipment, and their fields of application and limitations? Comminution is reduction of solid materials from one average particle size to a smaller average particle size by crushing, grinding, cutting, vibrating, or other processes. Comminution may be carried out on either dry materials or slurries. Crushing and grinding are the two primary comminution processes. Crushing is normally carried out on run-of-mine ore, while grinding, normally carried out after crushing, may be conducted on dry or slurried material. In comminution, the size reduction of particle is done by three types of forces: compression, impact, and attrition. Compression and impact forces are extensively used in crushing operations, while attrition is the dominant force in grinding. Primarily used equipment in crushing are jaw crushers, gyratory crushers, and cone crushers, whereas rod mills and ball mills, usually closed circuited with a classifier unit, are generally employed for grinding purposes in a mineral processing plant. Crushing is a dry process, whereas grinding is generally performed wet and hence more energy intensive. So, what are the laws of settling of solids in fluid? Settling is a process by which particulates settle to the bottom of a liquid and form a sediment. Particles that experience a force either due to gravity or due to centrifugal motion will tend to move in a uniform manner in direction exerted by that force. For gravity settling, this means that the particles will tend to fall to the bottom of the vessel, forming a slurry at the vessel base. For dilute suspensions, Stokes' law predicts the settling velocity of small spheres in fluid, either air or water. This originates due to the strength of viscous forces at the surface of the particle, providing the majority of the retarding force. Stokes' law finds many applications in natural sciences and is given by W is equal to 2 rho p minus rho f g r square upon 9 mu, where W is the settling velocity, rho is the density, and subscripts P and F indicate particle and fluid respectively, and G is the acceleration due to gravity, R is the radius of the particle, and mu is the dynamic viscosity of the fluid. Stokes' law applies when the Reynolds number is less than 0.1. Newtonian drag. So this is another law of settling of solids and fluid, and defining a drag coefficient CD as the ratio of the force experienced by particle divided by impact pressure of the fluid, a coefficient that can be considered as the transfer of available fluid force into drag is established. In this region, the inertia of impacting fluid is responsible for majority of force transfer to the particle, and CD is given by Fd upon half rho F u square a. For a spherical particle in Stokes regime, this value is not constant. However, in Newtonian drag regime, the drag on a sphere can be approximated by constant 0.44. This constant value implies that efficiency of transfer of energy from fluid to particle is not a function of fluid velocity. As such, the terminal velocity of a particle in a Newtonian regime can be obtained by equating the drag force to the applied force and resulting in the following expression: W is equal to 2.46 rho p minus under root of rho p minus rho f gr upon rho f. Now this is the third law of settling, that is transitional drag. In intermediate region between Stokes drag and Newtonian drag, there exists a transitional regime where the analytical solution to the problem of falling sphere becomes problematic, and to solve this, empirical expressions are used to calculate drag in this region. One such empirical equation is that of the Siller and Neumann and may be valid for Reynolds number between zero point 0.2 and 1000, and it is given by F is equal to F divided by rho F U square A is equal to 12 upon R Reynolds number into 1 plus 0.15 Reynolds number is to power 0.687. Now, what are the types of classifier and their selection and performance? So, classification refers to, sorry for the spelling mistake, classification refers to sizing operations that explore the difference in settling velocities exhibited by particles of different sizes. Classification equipment may include ore sorters, gas cyclones, hydrocyclones, etc. Based on their separation principles, classifiers are classified into weight classification and dry classification. And under weight classification, we can have again four types of classifiers: mechanical classifiers, spiral classifiers, hydraulic classifiers, and hydrocyclone classifiers. And under dry classifiers, we can have gravitational classifier, gravitational inertial classifier, and centrifugal classifiers. So first, weight classifier. Weight classification is based on principle that the separation of coarse particles from fine particles by water or any other liquid. In this technique, coarse particles move faster than fine particles at same density. High density particles move faster than low density particles at same size. Now, industrial participation classification for weight classifiers are as follows: hydraulic classifier, mechanical classifier, and cyclones and particles below a certain size and density are carried away with the water flow, whereas the coarser and heavier particles settle. So first is mechanical classifier, or in this we have a spiral classifier. The spiral classifier is also called as helical classifier. A spiral classifier is a type of mechanical classifier. A spiral can be of a single pitch or double pitch. Single pitch spirals consist of one continuous spiral ribbon, and the double pitch spiral has twice the racking capacity of a single pitch assembly and consists of two duplicate spiral ribbons. It is made by combining, sorry for the mistake, by combining a gravity settler of rectangular section with a sloped transport spiral for sediment. It consists of a semi-cylindrical trough, a trough which is semicircular. You can see here this semicircular trough is there in the figure, and inclined to the horizontal. So this is inclined in the horizontal. The spiral classifier rotates about the axis in the tank, and the sediments at the lower end are collected by the spiral and lifted upwards. Hydrocyclone classifier. Hydrocyclones are used in mining industry to separate minerals based on density and size. Slurry is vigorously rotated in the cyclone, which generates a radial force field, and large and dense particles are driven to the outer regions and underflow, while the small and light particles are attracted to the core and overflow. So this is the typical figure for hydrocyclone classifier. Now, hydraulic classifier. Hydraulic classifier is a device used to concentrate an ore based on difference between densities of ore and gangue particles. The process is called levitation. The powered ore is fed into a conical reservoir. A strong current of water agitates the powered ore. Lighter gangue particles rise up while the heavier ore particles sink down. Hydraulic classification consists of separating solid particles suspended in a liquid pulp into two distinct particle size fractions: fine or overflow and pores. Underflow. The principle of separation is based on effective size of the particles by difference in sedimentation velocity in a liquid. That this type of classification is made for particle sizes between 15 to 800 microns. Now, dry classifier. Dry classifiers are based on the air fluidization. Air classification is a process of separating categories of materials by weight differences in their respective aerodynamics characteristics. Dry classification using separation by centrifugal force typically covers the range of 5 micron to 150 micron. The process consists of interaction of a moving stream air, material particles, and gravitational force within a confined volume. The confined volume in which the separation takes place is called an air classifier. Gravitational centrifugal, gravitational inertial classifier comes under dry classifiers. Now, gravitational classifier. Gravitational classifiers are designed for coarse separation in the range of 12 mass size to 100 mass size. The feed material is spread over the width of the classifiers and drop as continuous feed curtain through top of the classifier. Air enters the classifier at low velocity through the front inlet and drawn through the feed curtain, which is dropping in front of the angled vanes on the air outlet. The air stream enters the feed curtain perpendicularly and draws finer particles from curtain of the material. The air current then draws the particles up almost vertical through the van wake. Gravitational classifiers are suitable for closing grinding circuits, de-dusting of coarser feeds, and reducing a high feed loading rate to a finer classifier, and it can also be used as a density separator. Now, gravitational inertia classifier. The feed material enters the top of the classifier in a downward direction, and the primary air enters the top of the classifier in a downward direction, and the air makes an angle of 120-degree change in direction and exits through the vanes carrying fine particles with it. The coarse particles, too heavy to turn, fall to the bottom to be discharged by a valve. Secondary air injected below the vanes passes through the curtain of falling particles. Those particles near the cut point in the size are diverted by secondary air stream into an eddy current within the heart-shaped chamber. You can see here this heart-shaped chamber, and fine particles, some captured as they enter the unit and the other drawn from the eddy current, are carried by exiting air to a fabric filter or cyclone for final recovery. Centrifugal classifier. Centrifugal classifier utilizes centrifugal forces in a similar way to cyclones to induce fine particle separation. The classifier has high degree of separation accuracy and low maintenance requirements. The classifier is used in conjunction with the dust collector and a system fan. Now, these are the questions asked in gate examination. Cyclones are primarily used for A. Comminution, B. Concentration, C. Dewatering, and D is classification. So, as we have read, cyclones are a type of classifier. So, the correct answer is D, classification. Hydrocyclone is A crusher, B weight classifier, C dry classifier, and D magnetic separator. So this is also asked in gate examination, and the correct answer is hydrocyclone is a weight classifier. Thank you for your attention.